Hi, I'm Mike Dano with Light Reading, and we're here at the big Mobile World Congress Barcelona trade show, and I'm here with Tamer from Globalstar. And you guys have had a lot of interesting news lately.
Yes.
I mean, you've got a new CEO from Qualcomm. You guys acquired XCOM assets. Globalstar has a big satellite business. I mean, they've got a deal with Apple for direct-to-device satellite messaging.
Yes.
Globalstar has a legacy IoT business. But you're here talking about private wireless.
Right.
Yeah. So maybe you can give us kind of your outlook on private wireless generally. I mean, there's been a lot of discussion in private wireless that it's not developing maybe as fast as some companies had hoped that it would. So I'm kind of wondering what the Globalstar view of this is. Are you seeing the same thing? Is this the right time for the market now? And then maybe we can get into XCOM a little bit. So go ahead and start there.
Sure. So definitely private networks have been around as an idea for a long time,
Yeah.
from 3G actually, and of course 4G, then 5G. There are reasons to believe that 5G is the right time. On one side, the application that are that 5G kind of claims, in a sense, are better in a setting of a private network. Like when you talk about things with very low latency, you cannot expect that to go all the way to some core network somewhere, for instance. The other thing is also most of the spectrum, the default spectrum kind of a thing for 5G is like the C-band, which is in a higher spectrum compared to 4G. So also the coverage is not that big. So there are reasons to believe that time is right for private networks. However, the situation is like that. It has been the case that customers for private networks would come to something like cellular 4G or 5G for application that they cannot cut it with Wi-Fi. Now, I claim that 5G current deployment of private network did not increase the scope or the spectrum beyond 4G. As in most of the application that 4G is covering, 5G is covering as well. It's not like they increased that kind of application. And I think the issue or the main reason for that is the way of deployment. And XCOM was designed actually to relax this and try to reach to other applications that kind of need to be enabled by that kind of technology.
And so the goal here is to cover what is uncovered right now.
In a sense.
In private wireless.
In a sense, yes.
Yeah. Okay. And so last week, Globalstar had sort of a big announcement for the XCOM system, and so that combines the acquisition of some of the assets of XCOM, that was Paul Jacobs' company, put it into Globalstar, and the bottom line is that this XCOM technology can take spectrum but make it way more efficient.
Right.
Is that fair to say?
Fair.
Okay.
Yes,
So maybe talk a little bit more about that. I mean, what is the goal here with XCOM? Who are you selling it to?
Right. Right.
What are the sort of
So I'll start
specifications?
with the last piece. As I said, we are trying to be enablers. We are not trying to compete on commodity applications. We are trying to enable application that without us, in a sense, will likely be wired or likely will not be done in a wireless fashion. So if you think about what XCOM is, and we call it XCOMP, you have maybe, let's say, an area like this area, and you want to have some kind of an application that is very high in KPI. Maybe it is very capacity demanding, if we take that as one metric. And you light one cell in the place, small cell, and it doesn't have enough capacity to cover the load that you need. So you light another cell. Now, when you do this in the typical deployment, you create two things. You create interference between these two cells, and you create boundaries for handover. Like you have to, and for KPI demanding application, these two can be detrimental for many technical reasons. Now, we're assuming we're hoping to double the capacity by adding the next one. It's not really the case. There's some kind of diminishing return, especially if you keep adding. So 2 are not covering your capacity, you put 3, you put 4. This is what the industry calls densification. You try to densify. And the problem of densification is these two elements that I said. And practically, 5G private networks try to avoid densification just because of what I said. The reality is, if you can simultaneously see the signals coming to all these cells or getting out from all these cells at the central point and at the right place in the stack, in the physical layer, you can remove these two things. You can remove interference and you can remove boundary. And if you are able to do this, every time you put one more access point or a radio unit, you increase capacity linearly. So you go from 2 to 4, you double. You go from 4 to 8, you double. That is actually the promise of the technology. Now, the central point came from the ORAN architecture or the CRAN architecture originally, because some of the splits of the ORAN architecture really cuts at the right point at what you need, the right point you need to be able to do this application. The rest is really math and many, many years of wireless experience.
Yeah. Okay. So last question. Globalstar is really working in this private wireless space, right? You've got the XCOM RAN system that you guys have announced, but there's also the question of band 53.
Yes.
Right. So Globalstar has talked about this spectrum band, and it's relatively unique, right? It can work with satellites. It can be terrestrial. I think it's about 10 megahertz. If I'm
yes,
right
it's
around.
exactly 11.5, but 10 megahertz is there.
Okay, yeah. Close enough, I guess.
Yeah.
And Globalstar has a spectrum, which is quite a valuable resource, right? Band 53. So it's supported in the 5G, 3GPP standards.
Right.
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 So how should we look at that? Is it appropriate for indoor deployments? Is it better for broad, deployments? How does that factor into all this?
So,
there's a lot going on here.
I understand.
Yeah.
So N53 or band 53 in 4G is, as you said, it's around 10 megahertz from 3GPP perspective. It's 10 megahertz. It's global because it was licensed for Globalstar for satellite, and it was then Globalstar was allowed to use it terrestrially, so you can deploy it anywhere in the globe. Now, as a spectrum in itself, it's an asset, as you said. You can imagine that it can be used for private networks. There's some power limitation in some areas, so it can be used. In other areas, actually, there are no power limitation, but it can be used. It can be used it augments the activities of the wireless activities that some operators have. But that takes us to the second point, which is the synergy between this N53 and XCOM. If you look at N53 by itself, it's only 10 megahertz, and it's a TDD band. So it is hard to squeeze a lot of capacity from this. I mean, you can see 5G, 100 megahertz is becoming the norm even now.
Yeah.
On the other hand, the scaling of capacity that I covered in XCOM can make it multifold. So it can make this 10 megahertz appear to be 8x more. So that can cover the capacity part. On the other hand, in absence of N53, we always target private bands around the globe. United States is our first customer, as the announcement we had last week. We use CBRS, for example, and CBRS has a coordinator called SAS, and it's very good and it's very important for the private network industry for sure. But in some application, it can be disruptive because it can be you may be asked to switch the channel or something like that. So having your dedicated spectrum when you deploy, it's like you go with a full solution like Wi-Fi. That's actually better than Wi-Fi because it's not shared. You go with a full solution where you have a technology and you have a spectrum, and this combo, you can deploy it and it's yours, nobody can touch it. So I think the synergy is very interesting. We improve the capacity of that narrow spectrum, and that narrow spectrum give us an opportunity and kind of uniqueness in the private network among all the private network providers.
Okay, sounds good. Well, thanks for joining us today.
Thank you, Mike.
Yeah.
Appreciate it.